Hello everybody, welcome to my channel. Today we have a very good problem for you guys called product of two sparse vectors, which is a very good problem. So make sure you pay close attention to the problem statement, right? So it says given two sparse vectors, compute their dot product, implement class sparse vector, right? Sparse vector takes in a nums, and initializes the object with vector nums, right? Okay. So the dot product, right? So this is the constructor, and then you see the dot product that will compute the dot product between the instance of sparse nums and this other vector that's given right to us, right? Okay, so he says a sparse vector is a vector that has mostly zero values. Okay, to store the sparse vector efficiently and compute the dot product between the two sparse vectors. Right, so this is a very good problem, as you guys can see, right? So we have a couple of asks here, right? We need to store the sparse vector efficiently. Sparse vector is a vector that has mostly zero values, right? We need to store it efficiently. And then we need to compute the dot product of the two vectors, right? So these are the two asks that we need to do, right? And it'll make a lot more sense to you guys once we get into why we need to store it efficiently, right? Or not, right? Let's go through the examples to really see, solidify the ask here. Okay, so we have nums1 and nums2, right? Those are the two separate vectors. And we need to compute the dot product of that, right? And so the dot product of those two vectors, 8, right? How did they derive to that, right? Let's go through the example, the explanation real quick, right? So we initialize each object, right? So we got, v1, v2, right? We pass in nums1 and nums2 respectively, right? And then we compute the dot product here, right? So we got v1 dot product v2, and decide there where we compute the dot product here, guys, right? So we got 1 times 0, 0 times 3, right? So the pattern here, how they're doing, right? Is they're multiplying, right? So for each index, right? So index 0, right? We multiply the values at each corresponding, right? So for index 0, right, we get the element at nums vector 1, right, which is 1, times the element at index 0 and nums 2, right, which is the vector 2, right? And they will multiply this together, we get 0, right? Then we also do the one for all the elements at index 1 as well, right? And both vectors. So 0 times 3 is 0 again. Then we do this 0 at index 2. So with this index 2 and nums 2, right, we do 0 as well. And then when we do 2 times 4, which is 8, right, which is the corresponding, right, and then at the last index, right, we do 3 times 0, and this is how to get, the 0, right? And then now we only left 8, right, so if you see anything multiplied by 0, it's going to be 0, right? So yeah, so we did the same thing here, guys. So we got 0 because, we got a bunch of zeros, right? And everything multiplying by 0, 0, right, and yeah, so this one is a little bit different. So you guys should understand the pattern for now. So each index, right, each index, we multiply the corresponding values in each array, right, each vector, right, and then we sum up the results, guys, right? Then whatever thing that we get, that's the result pretty much, right? So as you guys can see, right, anytime that we multiply by 0, right, we always get 0, right? So it's kind of a wasted computation, right? We can do a little bit better, right? And that's kind of where this thing comes into play, right? It says we need to store it efficiently, right? So we could, a straightforward way of doing this would be to simply, like the algorithm we just talked about, right? We just loop through the vector, right? We just loop through the vector. It will be as simple as that, right? So for each index, right, like we could even do it real quick. Notice how simple it is, guys, right? So nums, we do this, that nums is equal to this nums, right? Simple as that. And then, right, we just do just look through the vector, right? So the nums, that len, right? And do a plus plus here. Okay. Next thing you do, just do we could have a res variable, right, which is come up the vector sum. Okay, and then after that, what we do is to just do nums of I, right, times the vector of nums of I as well, right? So multiply whatever values at this first vector, right, with whatever values at the second vector here, right? So which we have access to, which is the other vector that nums of I, right? Because we have this class that has nums, right? So we can have access to it, right? Okay, and what we do, simply just to run code is as simple as that, right? It's not too bad at all, right? All right, so it's not bad at all, right? So we're good. It's not, we're still able to get the answer that we want. Okay, so it'll be pretty simple. So what I'm thinking the optimization that we can do, right? You can see that we were going over zeros, right? And the zeros are not very needed, right? You know, they kind of wasted computation. So an efficient way to store the stuff, right? And we need to store it in a way that we could ignore the zero values, right? You know, so every time there's a zero value, we can just not store it, right? And only store the non-zero value so that when we do the computation, we're a little bit more efficient with it, right? So by doing that, it's gonna help improve it further, right? You know, it's kind of, I'm pretty sure that's what your interviewer is going to be kind of testing you on, right? You know, thinking about the structure of choices that you could use to kind of efficiently represent this nums array that's best into us, right? You know, so how do we improve on that, right? So the way that I'm thinking, right, the straightforward way, you know, since we need to store the non-zero values, right, and not worry about the zero values, is to simply the there's just naturally, intuitively, right? What comes to mind is the hash map, right? A dictionary that stores, right? You know, so for the index, for the key, will be the index, right? You know, and then the value will be the corresponding value, right? So now, as we loop through each of the stuff, right? You know, if we encounter a, what's that called? For each index, right? So after we store, say we store an element, right? Say for the first noms, right? You know, okay, first nums we store, right? So it will look like that. Store the so index, right? It would be indexed to a value, like I said, right? And we index to value, right? And then what we're gonna do is to simply just build the first one, right? It will be one index 0, right? We have 1 index. So we'll skip over, right, this one because we don't store these 0 values, right? We only want to store the non-zero values here. And then we go to this index, right, which is index so 0, 1, 2, 3, right? We do 3 is equal to 2, right? And then we do the last index 4 is equal to 3 here, guys, right? So just like that, it will be, that's how it would look. And we'll do the same thing for the other one, right? For this other nums here as well, right? So it'll look, so just do it for clarity. All right, so we have our map, which is pretty simple. We will have the first index 0, where we don't store it, right? Index 1, we have 1 maps to 3, and then index 3 maps to 4, right? And then that's it. That's pretty much it we have here, right? So like we see, things are looking good now. So what we need to do, we'll just loop through the map, right? And then we see, all right, in this map, right, in the key set, right, map, and there for each keys, we see is there is corresponding index, right? Which, if there's a corresponding index, that means that we were able to find at that index, right, you know, there's a non-zero element there, right? You know, if it exists, right, you know. So you can see it doesn't exist, so we would skip that, right? So there's no need to compute, right? And then we do 3. Check, is there 3 there? Yeah, there's a 3 there as well, guys, right? So we must multiply the two numbers at those index, right? You know, and then we multiply them, and then we get the value 4 times 2, which is 8. And then just like that's how it would be, right? You know, so this will be a very better way of doing it, right? You know, we efficiently represent the sparse vectors, right? You know, we discarded all the non-zeros, right, and only stored the non-zero values, so that, because those are the ones that will be used for calculating the dot product, right? Because anything multiplied by 0, right, is a 0, right? So that's why we store it efficiently in a hash map, right? So that we can do that, right? You know. So yeah, guys, let's quickly go over the this solution, right? So what's gonna be, we said we're gonna use a map, right, to store the indexes and the values, right? So the key is going to be index, and the value is going to be the value at that particular index, right? So what we're going to start here is to initialize the hash map, right? Yeah. To initialize it, we're going to simply just look through the map, right? Simple as that. And then do I plus plus. And as we're iterating through, right, we check, right, if we encounter a non-zero value, right, because like I said, we're going to be prioritizing the non-zero values, right? We're not going to store the zero values because we want to be efficient in the storage, right? So we store the index and then we store the value at that index for value, right? We store the index because, right, we want to quickly look up, right, and the other vectors, is there a corresponding value, right? Non-zero value that exists, right? You know, that's where we store it indexed there, right? So we can do that easy lookup, right? Okay. So after we do that, we stored it in an efficient manner, right? By ignoring these zero values, right? Because we know that when multiply zero, we get zero, right? Okay, and then now we're going to do the same thing that we did in the other one, right? We initialize res to zero, and then we loop through, right? And index, right? We do map that key set, right? And then we're going to check, right? If there is there a corresponding non-zero value in the other map, right? In this second vector, right? Because we're inside the first vector now, right? And we're quickly checking is there corresponding non-zero value in the second index, right? Which is passed into us here, right? If that's the case, what I'm thinking what we could do is to just do map that, get the value at that index, right? And multiply by the value at this other index, right? Okay. At this same get the value at that the second vector, right? You know, at that same index, right? Yeah, you have to be the same index because like we did earlier, right? And then so we get the product of all the elements, right? You know, and we keep summing it up, and then we get our output result, right? You know, so this will only we only exit this piece of code if there exists non-zero values in both maps, right? You know, that's kind of what this is going to be useful for, right? Okay, you see, it looks good, right? You know, so if there's only one, let's say we have a non-zero in this map, right? And then we have a zero element, and it wouldn't exist in this map, right? So it would never hit this map, right? So that's kind of what this thing is, right? So you can see, this is pretty efficient, right? Pretty good problem, right? So there's also this other solution, right? That I want to also make sure that I mention it. We actually can go through it together, right? You know, because sometimes the reviewers, they don't accept this solution, right? Even though this solution is very intuitive, it's actually kind of good, right? And sometimes they complain about, there's might be a lot of collisions, right? You know, by reading through the comment sections, this discussion section, right? We see that sometimes they don't accept the HashMap solution, right? So it's worth mentioning the other solution I'm going to be bringing up, guys, right? Which is pretty elegant and pretty good, right? So we're going to quickly go through it. So the other solution I was thinking about is that, instead of storing it in a map, right, we could store it in the same piece up there that we have, right? Because we know that we need to capture two pieces of information, right? The index and the value, right? And we need to store it in an efficient manner, right? So what I'm thinking what we could do is to store, right? Store it in a paired data structure, right? So we store the index and a value, right? So we store that paired structure in a list, right? So it's going to be a list of pair, right? So of pair values, right? So that's kind of what it is. And then we will loop through, right? So it would look like that, right? So we would store, so the first nums, so list one, right? Would equal to, so the same thing we have here, guys, right? But instead of a map, we just store them like that. So it would be 0, 1, all right, for the first list. And then we have 3, 2, right? And then we have 4, 3, right? And then we will also loop through, we have the same thing for the other nums as well, right? Remember, we're only storing the non-zero elements, right? So it would look like, so we have 1, 3. We have 3, 4, right? For the second list, right? So in these same values, right? So we have that. And then once we have those two lists, guys, we can iterate through them at the same time, right? Using two-pointer techniques, right? That we're pretty comfortable with in this channel. We've done a lot of different problems that utilizes these techniques, guys. So how it would work, we would just loop through both at the same time. So we have pointers starting at the beginning, right? Of both lists. And it's sorted, right? Sorted by index, right? Because, that's how we're storing things, right? And then what we're going to do, if they're both pointing at the same index, right? And their corresponding list, right? Then we go ahead and do the dot product here. If not, right, then we need to move the smaller one forward so it can catch up to the element in these other lists, right? You know, that's kind of what it is, right? So this thing, you could think about the case of, let's say we had for list one, right? We had like, you know, the first 1,000 elements, right, being non-zeros, right? You know, so it would be 0, 1, 2, 3, 4, right? And then for list two, right, the first non-zero element that it encountered was at index of 1,000, right? So you can see that, you know, we would need to move list one, like, you know, forward, like, you know, 1,000 times so it can catch up to the first non-zero element that list two has, right? Because this is where it starts making a difference, right? Because anything before that doesn't matter, because 0 times 0, anything multiplied by 0 is going to be 0, right? You know, so there won't be a match, right? So to find the first match, right, we need to move it forward so that it can equal to the same index as whatever the bigger element is, right? The bigger index is at, right? So it's kind of what the output is going to be like, right? So it would be 0 is less than 1, right? They're not equal, so we can't do a dot product, right? Because it needs to have a match. So we're going to move the small one forward, right? Now the pointer will be at 3, and then the other pointer will be at first one still, right? And then we check, are they equal? No, they're not equal. They're different index, right? So let's move the small one forward. The small one forward is 1, right? We'll move it forward, and then we check, is it the same index? Yes, it is the same, right? So we go ahead and do the dot product. We do 2 times 4 equals 8, and then we're good, right? And then we go forward. We move both forward at the same time because we need to go on to the next one. And then we go out of bounds, and then we would be done with our calculation, right? Because, you know, there's nothing else to do because all the other because all the other elements in list 2 were 0 elements, right? So it doesn't matter, right? There's no need to compute, right? Because it's not going to help make a difference in the calculation anyway, right? So let's quickly go ahead and make the adjustments, right? It's going to be very, very simple, as you guys can see, right? So what we're going to do, we can use a pairs structure here, right? Well, I'm opting in for using just an array, right? That's going to store those 2 pieces of information that we want, right? Okay, so it's called a list, right? And then we're going to do list, new array list, right? So instead of that, we simply gonna store the list that add gonna be new int array of what? Of I and the nums, right? Nums of I, right? We're storing, that's how we decided we're gonna store, right? And then what's next for us that we took care of the first requirement, right? And then the next one is to just do the dot product, right? So what we're going to do is going to be a little bit different. Oh, we're still going to know results, right? But now we're going to need 2 pointers, right? So let's call it I, go to 0, and then j, right? So the I is going to look through the vector 1's list, and then j is going to look through vector 2's list, right? So let's quickly put that up. So vector it's going to equal to list that size, right? So the first list, right? And then j also has to be less than list that size, right? So second list. So we took care of that. And then we're going to do, guys, right? If they're both pointing at the same index, right? And the corresponding list, right? We check it. No. I meant to do list that get I, right? 0, right? Which is the one that's storing the index, right? For the non-zero element that we have, right? Does it equal to second list? Does it equal to second list index, right? Are they pointing at the same index, right? The corresponding list. If it is, then we go ahead and compute the dot product, guys, right now. So it will be lists. We're lazy. So 1, right? Which stores the actual value, right? And then we do the same thing here. Right? The value that it's pointing at. We go ahead and do this here, guys, right? Okay. We're almost there. So we compute that, and then after we do that, we also need to move both pointers forward, right? So we could go on to the next element, right? So now we're going to do, if that's not the case, right, they're not equal, right? They're not pointing to the same index, right? So we need to move the smaller one forward, right? You know? So if the index at the first list is smaller, right, then we go ahead and move that forward, guys, right? Else, then we move on the other one forward instead, right? right? So if it's smaller, I explain why that's the case, right? So let's press run code, guys. See if we pass. Okay, it looks like everything passing. Let's press submit. Awesome, guys. We're past all the test cases, guys. If you guys found value, you guys understood the thought process, you guys enjoyed the explanation, and it made a lot of sense. Let me know in the comment section if you guys liked it. Subscribe, like, and yeah, I'll see you guys in the next video.